over what? 3, which was what we were originally divided by, right? Okay, so,
Yeah, I just put R1.
oh, you just put
The
R1?
1 over 3.
Bad elementary teaching.
I was like, 8 R1.
Anyways, that's what it actually should have been,
R1.
okay? So here in this case, we're gonna be left with x, right? Plus 2, plus -1 over, what were we originally dividing by? X plus 1. And we want the integral of all that to be x. So could we split this up? Could I do the integral of just x plus 2 dx? Take out that negative, so make it minus, bless you. The integral of 1 over x plus 1 dx. Alright, what's the integral of these two guys? Because that should be easy. 1/2 x squared plus 2x. Okay. Then to get the integral of this guy, what would be u? X plus 1, what would be du? 1 dx. So this is going to go away with a u, this is going to go away with the du. So are we good?
Yeah.
So we got 1 over u du, which we know is negative what? This is a minus over here. ln, the absolute value of
X minus
u plus c. Some of you already knew what to do, which is awesome. X plus 1, right? And I kind of went through the whole long thing there. Okay? On the next couple of examples, we won't have to go through all that, right? Cool? How was that, okay? Then after you did that on your question on the mock exam, you wouldn't put plus c because it was a definite integral. You had to evaluate it from whatever number to whatever number they gave you. Okay, and I wouldn't find my new limits on that one because only one part of it is in terms of u. I would rewrite it with the x there and then just leave the limits the way they were. Because if not, I'm gonna have to change these guys to be u's and that's gonna be crazy. Okay? Try number 6 here. Try number 6. Does it factor? First thing you ask yourself. No, the only thing that gives me 7 is 7 times 1, and that'll either give me an 8 or it'll give me a 6. Okay? So the only way to get through this problem is to actually divide. So let's do the synthetic division. What goes inside? 1. No zeros? Why no zeros? Because all their terms are there, right? From the second power down to the... Okay? What goes on the outside? -2. What do I do with the 1? Bring it down, then I follow mama. So 1 times -2, add, times -2,
Positive 14.
plus 7. That's my remainder. I start with 1 power less, because we're dividing by x, something linear. So this is not x squared, this is what? X. So we have the integral of x minus 7 plus 21 over what? X plus 2 ds. So let's separate it. The integral of x minus 7 dx, take out the 21 guys, times the integral of 1 over x plus 2. Now you're ready to go. Let's do it. What's my antiderivative? 1/2 x squared minus 7x plus 21 ln of the absolute value of x plus 2. Do we have our license to integrate? Yes, because the derivative of this guy is going to be just what? 1, right? Do I have 1? You can think of it as 1 over u, right?
How do you make that?
Cool? Try the last one by yourself.
Yeah, random.
See what you got.
Yes, fine. Yes, I know.
Squeeze it.
Not my mom. No, you didn't.
You're doing it right? Uh-oh. Help her. Tell her what she did wrong.
Put the zero. The zero.
You didn't forget the zero?
Wait, Robert, do you have a class again? Carter?
Tell her what she did wrong, Ricky.
Oh, you forgot the zero.
Tell him what he did wrong, Ricky. Come on.
Zero.
Tell him what he did wrong, Ricky. Tell him what he did wrong, Pablo.
Forgot the zero, Mike. God damn.
Tell her what she did wrong, Pablo. Tell Martin what he did wrong, too.
People already do that on a daily basis.
You gotta do 1 because there's no x squared. So you gotta put it for x squared.
Good job.
Like when you divide, right? So like when you synthetically divide. Alright, here we go. Right. So your function is x cubed, right?
Right, so what is it missing that we gotta watch out for,
So
guys?
then, because you want power.
It's missing the x
I guess you
squared,
don't want-
right?
So then you do 1, 0, negative 4, 1. So that way when
Remember, one of the things I told you to watch out for was that all the terms were
you gotta remember
present.
that.
Okay? So this will be 1, 0, negative 4, 1, right?
What's that?
What goes on the outside? Negative 1. Bring down the 1. 1 times negative 1, negative 1 plus 0, negative 1 times negative 1, 1 plus negative 4, negative 3 times negative 1, 3 plus 1 is 4. Cool, you got it? Alright, we start with 1 power what? Less, so this was cubic, so this is squared. And the last guy is our what? Remainder. We have the integral of x squared minus x minus 3. Can I stop it right there? Plus, can I take out the 4? Times the integral of 1 over x plus 1 already? Or did I lose you? The remainder would have been 4 over x plus 1, right? But I'm taking out that 4 already because that's what I was going to have to do anyways. Are we okay? Yes? You sure we didn't lose you?
Yeah.
Alright, so let's integrate. What do we get? 1/3 x cubed squared plus 4 times ln absolute value x plus 1 plus beautiful. Okay, so a couple of things to look out for, right? Remember that if you're missing something, you don't forget to put that 0. That's gonna cost you the question. Okay? Got it? Alright.
Oh, I'm sorry.
So I'm gonna keep going just so we can finish the notes, and then I won't have to come back and talk anymore. I know you guys hate listening to me. So the last problems we're gonna talk about are the integrals of the other trig functions that we didn't look at. All we looked at was sine and cosine, right? What's the integral of sine? Negative cosine. What's the integral of cosine? Sine, right? Those are the ones that are opposite from the derivatives, right? Okay. Now, for tangent, cotangent, secant, and cosecant, it's just going to be a matter of you memorizing them. But I'm going to show you how to do the tangent one by hand, and the other ones are quite similar, okay? It's just, it would take a little bit of work. Usually on the AP test, there's like one question regarding this. I don't know which one they're going to give you. Hopefully it's like a secant one. or a cosecant one, because those are pretty easy to remember. Because it's related to the derivative, right? So like if you think of secant, what's the derivative of secant? Secant tangent, so it has the secant and the tangent in there, it's just with a plus sign, right? Same thing for the cosecant, cosecant, cotangent. These are the ones that I don't know how to relate them to what we're doing. But maybe you can figure out a way to memorize them and remember them for the test. Okay? So if we think about this one, it's really the same thing as what over what? Sine over cosine, right? So if I ask myself, which one would I like to be u, what would you pick? I would pick cosine, because it's in the denominator, which is usually where the u is. And when I get the derivative of cosine, it's going to be what? Negative sine dx. So I got the sine and I got the dx, except I got this negative here. So that's easy, we can move it to the other side, right? And now I have a super easy problem to work with. So negative the integral, right? This was u, and this went away. So it's just 1 over u du, which we know is what? Negative ln of the absolute value of u plus c, which is negative ln of the absolute value of what? Cosine of x. So it's not hard to come up with them. I mean, it's totally doable. You would just have to work with them, right? Again, there's more than likely going to be only one question on that AP test where they require one of these integrals. The ones that they're going to be more commonly asked are going to be sine and cosine. Those are the ones that kids usually mess up. Those are the basic trig ones that you should know. Okay? So let's go through a couple of these and see if we can do them, alright? Look at this first one, secant of 7x. So we're looking at this rule right here. What would we want u to be? 7x. What would du be? 7 dx. We got to get rid of that 7. So it would be 1 over 7 du is equal to dx. So now we could say that this is the integral, 1 over 7 times it, of secant of u. We can follow the rule, right? That should end up giving us 1 over 7 and then the absolute value of secant of 7x plus tangent of 7x plus. What do you notice we had to add on the outside because there was a 7 in here? A 1 over 7, right? Because the license to integrate would have been a 7. But there's no 7 here, right? So I would have to put a what out here if I put a 7 there? 1 over 7. You understand? Okay, so that can kind of help us to be able to integrate these a little bit faster. Right, so this one is putting 2 of them together. So what are we going to have on the outside because it's not provided there for us? Alright, so let's see if we can jump straight to the answer. So we would have 1/2 ln, the absolute value of what? Secant 2x plus tangent 2x. Now we need this one for tangent, right? We don't have the 2 on the outside, so we need to put a what? A half, right? And what do we say the integral of tangent was? Negative ln the absolute value of cosine of 2x plus. And I'm getting that from up here. Okay? Cool? Try the last one. What would be the license to integrate here? Well, the license to integrate would be half, right? I don't have a half here, so if I add a half, I have to put what on the outside of the integral? A 2, right? So this one would be what? 2 ln of the absolute value of secant of x over 2 plus tangent of x over 2 plus C. Cool? So, I personally think they're gonna either ask a secant or a cosecant one. Okay, just remember that the secant one is the ln with the secant and the tangent being added. The cosecant one is going to be the ln, the negative ln with the cosecant and the cotangent added. Cool? And the shortcut, again, remember, is to look at the argument, right? We got a 2x in there, we're missing a 2, so we gotta put a 1/2 of the x. Cool? Too easy? To help you remember, the ones that are weird are the cotangent and the tangent.
Oh, tell me what
How would you
you're
connect
trying to
those?
do. Right foot, and then you inject it and
Yeah, you can.
some shoes or
Yeah.
so superstars? Someone? Adidas sweatpants though?
Well, it's just like,
Nah,
think of it as
they told him to
like
return
whatever's on the bottom.
Adidas.
Like for tangent, cosine on the bottom.
Those are pretty